So, hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 143, and in this video we continue with our repetition of the keywords, and of course we extend it a little bit so that we learn a little bit more than just repeating the keywords. Alright, and like all time I'm using the CPP reference.com web site because we want to learn this documentation here a little bit, so we can read the official documentations after we finish this tutorial, so we can look after all keywords ourselves and understand them very well. But there is still a long way, but we are good to go. So with that said, I continue now, and like all time I will read the question. You should pause the video, try it on your own, and then continue the video after you tried it, and then you can compare it what I have and what you have. And of course I will not pause the video. I mean, I will just continue with the solution after I read it. And yeah, let's get into it. So first question, it is 41 here, and it says what is keyword Inium, and why is it bad, and what is better? So we have here 3 questions actually, and pause the video like all time, try to answer, and I go on with the answer. So first question, what is keyword Enum? Enum is just we create with Enum actually a new type, which is an enumerator type. Okay, and then let's go on. And what is that? Yes, it is just a enumeration type creator. So why is it bad? And let's see, why is it bad? Why is enumeration bad? Because this enum keyword here, it's one of these older keywords, which means they have not considered the situation that there is an implicit conversion to int, because this enum here can be converted to an int, and that is considered to be bad. And it has also other bad things, like the enumerators are in the scope of the enum, which is also bad. So we have there several bad things, and let's see what is better. Yes, that's very important here. It is actually the Enum class, because it's similar like Enum, it is Enum class. And now let's switch to the official documentation and watch this a little bit closer. So here is Enum, and here on top we have our enumeration and the declaration, and here's our keyword Enum. But there is of course a little bit more than Enum. The new version is, for example, here Enum class, and there is also something like Enum Struct, which we have not learned yet, but in future we will, after we learn structs and so on. So important is here, actually this Enum Struct is has nothing to do with a struct. I think it says just the same as a class, so we could use this one as well, but we have not talked about it yet. We will talk about it. So with that said, yes, let's see what they describe it here. If you want a little bit more detailed answer what an enumeration is, it's here. Include several explicit named constants. Yes, that's not so important. I think let's try to write here short answers. So what is the keyword enum? It declares a new enumerator type. Of course, this is not the only answer, but I just write here one answer, so it's not too long. And why is it bad? Converts implicit to int, and enumerators are in scope of enum, and there are much more things, but that's enough. Enumerators. And what is better? Better would be Enum class or Enum Struct. And That's so the short answers. And of course, you should read this kind of answers here a little bit more in detail. We have here this Enum Struct and so on. Here are, yeah, we will see this a little bit more in detail. I think there is a second question, and yeah, let's go to the second question. Here, important one note before we go on: this implicit conversation to int and this enumerator are in scope of Enum. This one we have not talked, but this one is more a theoretical part, and you should read this a little bit more in detail if you want to know more about that. So let's go to number 42. What means scope enumeration? What means unscoped enumeration? And then it says here, explain the syntax. And then it says here, write an example for each. All right, that's a lot of stuff again in one number. Let's start here. Let's pause the video and try, of course, and I will go on, of course. First of all, what means scoped enumeration? The answer for that is, it is just Enum, just Enum. Just Enum is, oops, wrong, other way around. The scoped enumeration. If I make this, I wanted this one actually. For example, here, this unscoped enumeration first. Why I have this one here, I don't know. Ah, okay, then not so. Then just Enum class and Enum Struct. All right, this one here. Then what means unscoped enumeration? It's just Enum. This is just a short answer. This is not the right answer. Enum, we will see this in a short, but let me write here these answers here, because yeah, you will see it in a moment. And then explain the syntax. Now when I explain the syntax, then you will understand what I mean with this one here. Let's copy the syntax here so that we can see it. So we are here still in enumeration, and you can see the unscoped enumeration is just the keyword Enum, right? And that I mean here just Enum, the unscoped enumeration. And the other one is here a little bit down. The scoped enumeration is here this Enum with struct and class. Of course, there are different kind of syntax, but it's okay. So with that said, we have cleared the first two questions here, but let's try this one here. This one, explain the syntax, which means I have to write now syntax for this one, and then I have to write examples. And I hope you can make this, because that would take a long time if I would write now all the syntax down here and make it so I just explain the syntax. So let's go to the syntax. First of all, we start here on top. And on top we have here just a different kind of syntax, and we will not go through all because yeah, it will take too much time, but we go at least the one which we know. So let's start with here. We have here Enum K, and you see attribute is optional. This we see all time, right? I hope you get used to it, that this one is this attribute, which means this square brackets. This Enum K here is here our Enum K. You have to choose Enum, and then you can choose the plain Enum, the Enum class, and the Enum Struct. And that's why we have here an Enum K, because we have now different versions of Enums which we want to choose. All right, this one is clear. Attribute, it should be clear. This is the square brackets, and then you have see if these attributes are useful in this case, and read the attributes which you want to use. Then we have here Enum head name optional. Let's see, Enum head name here is our Enum head name is just the name. And then we have okay, you have, of course, it's not just the name, it's a little bit more. You can read this through, but we make it a little bit short so it's not too long, and say it's just the name. And then we have here Enum base, and Enum base, when we read here, you can see it is a type specifier sequence, and it specifies the type of the enumerators, and you can read this one here. All right, and then we have our curly braces, and then we have our enumerator list, which means all these enumerators which we write in. Let me copy the syntax here. Let me jump to my main. At least let's see. I have here some examples. I don't know what I have here, but let's kick this out for a moment. Let's print our syntax here. Let's make here control comment. All right, and let's do at least one of these examples. On top was, what was it? Here it says, where was it? Why I have not a jump there. It says here we should explain the syntax, and we should write an example of each for each. So I have just here the syntax for this one now, and I copy now the syntax for the other ones too, because we need an example for the other ones. And you see the other ones has a similar syntax to this one here. So when we covered one, then we covered the other ones as well, almost. But you can see we have here different kind of syntax here. Of course, we have here also different kinds here. Let's see if this is so much different. No, it's not. Actually, I could copy this one. It's similar. It has a comma and more input. And then we have here this one here with Enum head name, where we have to use the Enum head. All right, we will not go to all syntax, but like I said, that would take too much time. But let's copy this syntax here. Let's copy this one here. And let's go here to our main. Let's see what I have here. What is that? I don't know. Don't know. So let's paste this one here. Let's make here a comment. And let's copy. There is, of course, this other one too. What we skip this, and let's copy the other syntax for the scoped enumeration as well. Let's copy at least one of them. Let's copy this one. I don't need to define here. And this one, the first one, at least one, right? At least one. And then we have this one. Let's make here a comment too. And now we should make examples, but these examples we should all time rely on this syntax. Let's try to use the syntax. Let's see if we can use the syntax. Then we will understand the syntax as well. So okay, let's start. I start with an enum k. Enum k means enum, enum's the class or enum. So in this case, let's skip this one actually, because this two here are anyway a specification of this one here. So we can keep this one, but I skip this syntax for this one, and I write just two syntax for them, because here I will anyway use Enum and Enum Struct. So that's why. Let's do it this way. All right, Enum is my thing what I have to use. The name is optional, but in this case I want a name. I call it color. And then this one I need, and I need this curly braces, both. All right, let's write this one. And then I need this enumerator const expression. Actually, I don't need this const expression here, I think. Is this not optional? Okay. Normally this one is here not needed. It is optional. Let's see why they have it. Probably I make one of this one, that's why. So this one is not actually this here. Oh, that could be wrong what I'm doing, but whatever. It's okay. Perhaps I make just this one here. Because it says here we need here equal const expression if we make the unscoped one. But in my case, yeah, normally it's not wrong, because I want to just make here this example here. Let's copy this one. It is actually the same example here, and I'm a little bit irritated because this one it says we have to use this const expression here an equal. That's not true. So let's go on. Okay, then I write here some colors: red, green, blue, and that's it. And actually that would be this example here. And when we look their example here, we have their example here on the bottom. You can see it's exactly the same what I did here. I was irritated, and I hope you're not too, with this one here, but probably I misread this a little bit. Should I read a little bit more in detail if we really need this equal sign? or perhaps I'm blind. Is this black or is this not black? I'm not sure, because if it's black, it means we need it normally. If it's not black, we don't need it. Okay, anyway, probably this one is more like the first one, I think, than this one here. But they made the same example here, so I say it counts. All right, let's go on. The second one here, let's make it with a struct. Enum Struct, the same here. Enum class. This time I call it just database, something like that. And then I have used the Inium here. I have used one of them here. Class, I used in this case class. They are similar. Actually, that's why I said perhaps we don't need to learn here struct, because this is just called struct, but it's not really a struct. And yeah, they are equal normally. But yeah, let's see. Then I have to use a name here. Yes, I have here a name. Let's see if this is okay in the definition. And we see here the definition says, yes, you have to choose a name here. In this case, yes, I have chosen. Now you make here this curly braces. So let's do this one here. And again, this one is not that what I'm using. I'm using more like this one here on top. Here, this one, an enumerator list. So this enumerator, I don't know why they have here const expression. And they say we have to use it, but they make not an example with it. It's a little bit strange. So I just use this enumerator, and this is probably just optional anyhow, but it is not signed as optional. That's why it's a little bit irritating from the syntax, at least from this one here. And let's say here something like first book, second book, and third book, and third book. All right, something like that. And yeah, that's it. And when we saw here again, they used here again here the same example like before, and we can see this const expression here. Probably they mean it this assignment of the underlying integral to define it, perhaps. But what is irritating is it is black, I think, or I'm colorblind a little bit. It's not real black. Let me see this. Also, in my eyes is this black, and normally what black is, like this one and this one and this one, these things you have to use. But you see here in their example, they used it only one time, and here not. So it's not a must. You can use it. All right. That's why it's a little bit irritating. And yeah, okay, we made this. So I made this something too. Here I made it one with Enum and one with Enum class. I hope you made this something like similar. And yeah, we can talk about their examples here a little bit, so that we get used to their examples instead of our example. So I hope you made here some examples. It was not very difficult actually. And yeah, let's go first back to our place. And here, just Enum. Let's see what we had writing example for, but explain the syntax. Yes, more or less. We have not really the syntax. I should explain a little bit more the syntax before I go on. So here, the first one, I hope I explained this one right. And now the second one is just that we have here a little bit more is comma separated, which means it more. We have here more enumerators like red, blue, green. At the first one, we can have nothing in it. And this means enumerator list optional means we can here have nothing in it and it's still okay. And let's go here to the last one. We have here again enum k, one of this one, attribute like all time optional. We can kick it out or use it when we know which attribute we want. And then enum head name is just this one, what I read here, just enum name, or in this case, but read here a little bit more in detail what they mean with that. And then enum base, this one we have never used till now, this enum base, which is optional. Optional means you can use it or not, which means you can define a type for your enumerators, which is in this list. For example, you can say which this list type is. For example, red, when we have here red, green or anything, and then you can here specify the type. There will be an example here below. For example, in this unscoped one, when we watch this syntax again, it starts again with Enium name. You can optional make a name, depends on the situation. Normal syntax is all-time username, and then you have here again this enumerator. And here, that what irritated me a little bit, that we have a sign, and they make here an example without this sign, which means they are not using this const expression here. Even this should be used, but perhaps it's not absolute correct here. And yeah, but it's the same, it's almost the same. So with that said, the first syntax is okay. I hope you understand it. You make your enumerator, for example, this color red, and then you go to, you could make here a const expression. We have not talked about this const expression. It's similar like a const, but has a little bit more better features than const. And sometimes you need both, so we have not talked about it. We talk later about this one. And then, yeah, it's a list, and this means just it continues here if you want more. All right, the second one, like I said, we have this Enium, then we have here name, and then here this colon type is exactly what I showed you here on top. It is this Enium base actually. You can select here a type. So you specify, where is it? You specify a type, and this type is one of this one here. I mean, this type belongs all to this enumerator, which means if you would write here color colon type, then red, green, and blue would be this type which you specify here. Of course, it must fit. And then this one here, yes, this one works even also, which means you just write here Enium, for example, color, and then you write here, for example, std string as colon or int, for example. Let's write the colon int, and then you don't use even this curly braces. And yeah, this is strange, and I just go through this fast so that you can see this syntax we are going to learn step by step. We have not to understand all right now. That's not very important right now, but later, yes, not now. And when you go here a little bit this examples now, you can see what happens here. Let's see. Here that was our example, and here they printed this one out. And let's see what happens here. Can you see what happens here? Try it before I say it. Pause the video and try it. It's very not too difficult. But no, but we have not talked about it. That's the problem. In this tutorial, I said that this Enium, this enumerators here, this ABC, they are converted behind the scene to integrals, right? So you can see it starts with 0, 1, 2, 3, 4, 5, and so on. But here you can even change this integral numbers. So it says here 0, 1, and then you set C. This one is your own setting to 10. Normally it would be here, for example, 0, 1, 2. Normally it would be here 2. You set it 10, and all the other ones are now go on from 10, 11, 1, and so on. And you can see this. And here what they do is they reset it back to 1, which means it starts here again. But this one is normally a conflict, because now you have this one here. But not really, because yeah, we have not talked about what happens if these are both the same. Or can we do this? Because normally it's below, yes. Behind the scene, it's now associated with this number here. And what happens with this one? Perhaps it's allowed, perhaps it's not. We have not talked about it, but in further tutorials. So let's go here a little bit more about this. You can read this one here, and then you will see, or this one here, how they described it. And yeah, let's go here a little bit more what we have here. And this one is again the same thing here with this color, yeah, what I showed here with this type, with this probably this const expression. You can again skip this one here. It's just setting this number. It's similar like here. You start red, yellow, green is now 20, which means here integral behind the scene, this integer number is 20. And you can see here that int n equal blue is n equal 21 possible. This one is very strange. because yes, this is only possible with Inium. This here, with Enum class, it's not possible. And that's why, this is one reason why it's considered so bad. I hope you remember this kind of stuff. I think I talked it shortly, but I have not talked about this constant expression behind the scene so much. And yeah, let's go a little bit further and see what we have here. What we have here, Enum access. It has here again just, in this case, it's using exactly this definition here, this const expression, and you see it's just a number. Like I said, const expression is similar like const. It's only a little bit more better in some places, but where is this again? Where here we are. And then you can see here 1, 2, and so on. What is this? 1, 2, 4, and then 1 is range null 7. Yes, we have not talked about this one. Later. Static cast, we have not talked. Let's skip this. And have we talked about this one? Except what is here? This is just again a logical operators, and they are just combining this one logical with this one. Yes, and let's skip this one as well, because that's you can try it, of course, for training what it gives. You can just copy this code and start and see what happens. Static cast, skip again, skip Enum foo. Here what we see here is, okay, this is again range. They are just defining here range. It's not very important. Let's skip this one too. So let's see what we have here a little bit. Again, they are still working behind the scene with the range, setting it here and so on. I think when you understand this on top, then you will understand this one here as well. It's similar, but the difference is here you can see is an expression, right? So we can calculate even this range here. Anyhow, this one we can skip for now. It's a struct. And then we have here, yeah, we skip this one here. We have not worked with structs. And then let's see what we have here. Again, struct, we have not talked about struct. So that was this examples here. And I hope you understand some of them, not all of them, because we have not talked about all. But little by little, you should understand some of these examples. All right, and here on the scoped enumeration, I think I skipped this now, and you can try to go through these examples here on this side and try to go through only which we have talked in our tutorial. And if you want, go try to understand the other ones, also very nice if you can, and see why it's so and why not so. With this one, we have not talked the using keyword in this case. I think we have talked about using, but we will talk about this later in this tutorial. So that was long talk about enums, and yeah, let's see, explain the syntax. I want to just go a little bit over the syntax so that you get more and more familiar with this one, at least a little bit, and try it on your own, of course. And if you read them, you get better than me, no worry. And yeah, let's go on. So the next one here is 43. It says here, what means keyword false? Explain why can you use number for it too, and how you use it. All right. Okay, first of all, I hope you pause the video. It's not too difficult. False means just a bool statement. It's just a bool statement. It's just a bool which says yes or no. Oh, in this case, which says no. Oh, which says no. I mean, this is not a very accurate example, but you understand it. Which says no. So, for example, you evaluate anything and it says no, false, right? We can say false, we can say no, or the second question here, why can you use numbers for it too, and how you use it. So the second question would be no, false also means 0, that we learned in C++. That's specific for C++. You can use 0 as false. All right. And then we should explain this a little bit. Yeah, let's go here and try to explain this a little bit. We jump here, we go to the Boolean. We have here the syntax for true and false. False we are talking right now. And you can see it is just a bool literal. And we can output it to true, false, 1 and 0. And my answer, my first answer, says just no, is not true. This is just random talk. But it's understandable what it means, right? No means false, 0 means false. And yeah, the problem here is this question here, what it says. Why can you use numbers for it? Because yes, it's C++ implemented 0 as well as false. That's why you can use numbers for it. When we watch this little explanation here, this bool alpha means just you can convert this true to a number. And this one, no bool alpha, means don't convert. Sorry, other way around. Bool alpha means bool alpha means true, which means use the letters, and no bool alpha converts this true to numbers here. And you can see here the output of this one. This one is not important, but important is just that false is 0. You can see it. And all other things are actually related to 1, and that's strange. So careful about this one here. This bool alpha treated true as 1, but this is not really true. I mean, it is true like this definition here is 1 and 0, but if you have, for example, a while loop, an if condition, and if you say there, for example, the number 42, this is also converted to a true statement, right? So true is not only just 1, but 0 is just false. Also false is just 0, but true can be any other number than 0. This comes here not so out, but let me make you an example. Not too difficult. When I write here if, oops, not so, if 42, for example, this becomes true. And let's see if this is true, as it is here out. Is this true? Is this true? And we can see when I start this one, you can see it prints out, which means this here was true, right? And that's funny thing is that works for negative numbers too. I make here minus 43 and I start it. You can see it prints out. Okay, that was not good. Let's make it again. One more time. Now, so you can see minus 43 is this true, and that means that one is also related to true. Only 0 is false, right? Only this number 0 is false. When I save this, start this, and you see this one is not printed out. So keep in mind here, not just the number 1 is true considered, and this one is on, I mean, official, yes, 1 and 0, but in special cases for loops, for example, they are converted to a bool, and the bool must be not number 1, like you can see here in this case. That was very important, I think, because that was also some mistakes. And we can go back now to our questions. Let's go and see what we can figure out. And where we are, here we are. So this was okay. Okay, this one here, let's write here one more thing. All other numbers then all other numbers, or let's write all numbers without 0 is treated true in if. It is true, is treated true. Okay, that you understand this, right? Only 0 is treated false, all others can be true. So let's go on. Let's go on a little bit. So what we have here, 44, it says here, what is the difference about float type and double type? First question. Second, what should you prefer? Okay, that was second question. And then run this example code and explain it. So this is here the example code 1. Here is another example code 2. And you should try run it and explain this code here. So let's start first before we run anything. Let's answer the questions here. So I answer this question here first, which says, what is the difference about float type and double type? What is it? The answer is double has more precision than float. And so that's the difference, because we will see in a moment how much. And then, so this is the difference. Of course, there are a little bit, but this is the main difference. Let's say, of course, you find more answers than this one. Let's continue. What should you prefer? And that's a little bit not so easy to answer. Let's say, in general, double, but depends on needs. So the question is now why we should prefer in general double and not floats. First of all, what is a float and what a double? Make an example here. Fast example. Double is this one here. Double. Let me show you this one here. Double. My double number. And here is my double number. That's it. And here is my float number. My float number. And here is my float number. And F. Don't forget with float that you have to write this F, so it makes sure that this one treated as a float. And yeah, so we are talking about this 2 here. The question is now, I said here, for this example, what should you prefer? In general, double, because we have here the answer. One answer would be because of the precision, you should prefer double, but double has a big negative side as well. And and that's why I said depends on needs. What is the big negative side of a double? Because double is definitely better than float, and if we have double, that works 10 times better than this one, or depends on the precision setting. But the answer is why we can't use all-time double is double take more space on your memory. For example, we know this float, I don't know, perhaps take just 4 bytes. I have not tested it, and this one take 8 bytes all time. So you can see that float can be smaller in size, and then it results also to float can also be faster than double, which means double has more precision, but this precision has to be calculated, which means the PC need more time to go through this precision than for a float. And that's why I said, but depends on needs. For example, if you don't need high precision, for example, in my case, let me make this one. Here, in this case, here, I don't need precision high. Here I have just this float number. And if I write now here the same thing with 3, this one is faster than this one here. All right, so there are many different things to consider. We will talk this a little bit more here with these examples here. All right, let's see. Let me see what I can show you here. Here we are here again to this fundamental types. We are here down to our floating point numbers. We will talk here a little bit more. But before we talk here a little bit more, let's see. Yes, here, this floating point had single precision. You see, single precision floating point format. This looks a little bit too formal. So if you have not learned maths and formal language, don't worry about this. We don't need this really this detail right now as a programmer for starters, because we are programming. This is just math explanation and so on. And here this one is example. This important, this picture. If you understand this picture, that's it. You see the float here has around this is one example of its precision. This one is 32 bits long. And it says here we have a start bit, which is our sign, which means it can be minus or plus. And then it has here some exponents here. And then this has a fraction and so a little bit precision, fraction, and so on. And yeah, and when we compare this picture, just forget this math here right now. It's just the same in math explanation. So for example, this picture here on top is the same what he's doing here in math, and here which yields then in this one here. And this one is not so important. Just understand this one. This is 32 bits. And now when I compare this one to a double, you can see this picture here is now for the same thing. And now we have a high more bits, right? In this case, we have 64 bits. And with 64 bits, we have more precision. That's so, let's say, that's so, that's so the answer which you should know at start. This here, it sounds now, it's when you go in detail, it becomes very technical, very mathematical, and too complicated if you don't know how these mathematical things are, what these mathematical symbols means. For example, you see this is a little bit not. It's a little bit high math, right? So what you learn in university and so not in normal school. At least some of the symbols here. So don't worry about this too much. It's not important for programmers right now. And when we need something in math, we just take it from libraries, which means we don't calculate anything else ourselves. We are just yeah, like I said, we will just take it from libraries and let the computer calculate it or use a calculator. That's it. So let's continue a little bit here. I hope you tried this example here, because this example here, what you see, will print out strange things. Let me show you. I copy this one. I jump to main. I paste it here. And let's make an uncomment here. All right. And here we have this one, and it starts here with a problem because this one should be commented. All right, this is the example which you should check and write. Doesn't matter if you understand not this one here, just understand this number. First of all, it starts here. This one is a division. I divide 1 by 3, and we know that something this is normally expected, right? This number here, 333, it would go on, it will not stop, it will not stop, it will just go on. So, but what happens with the PC? I mean, what happens in our compiler, how he is treating this number? And I start it now, and we see what happens. So what I see is, first line, it looks good, it's a float. Second line, it looks actually very good. It's a double. So both float, the first line is a float, the second line is a double. And we talked about float and double, right? The double has more precision, float has less precision. Both gave us the expected numbers, no problem. But now the same thing here. Again, the top line is a float. The second line is a double, and this one is just setting the precision of the output a little bit more, that we can see what happens after the default output is only 6 digits or something. But with this one, you tell the output here, this operator here, please show me not the first 6 digits, show me the first 16 digits, which means if you count these numbers, this should be 16. And yeah, let's see what happens. But here happens something strange, right? The first one is a float, the second one is a double, and look what happens. The float is not printing out that what we expected. Expected was this here on top, 3, and it started to print out something 4, 3, 2, 6, 7, 8. That means we have a problem with float. So the double here on the other hand, he printed still all nice till this point at least. What happens if we add some more things? Let's test this one. Okay, this double has already crapped, but let me add here 3, and let me add here also much. I don't know if my PC works, but let's see. Now I add both much. Let's see what happens. I start. And this one is not accurate because I have to specify here the output. Like I said, this one says print me out this one a little bit more. Wait a second. Yeah, which means I have to set this one higher, sorry. So let's set this one here to 32. It's enough, I think. Let's set it to 32 digits. And I start. And look this. I set the double is very nice, but when you look now the double, oh, it starts to crack too. So the expected result is this here. This is accurate. But our PC, the more digits we have here behind, it starts to make crap. It makes problem. And this one, I can't explain it right now in this video. This has something to do with how the PC is treating numbers. What you should know is probably that numbers are created. So let's say so. The PC knows only bits. I hope that you know that PC works with bits. Bits means just to yeah, you have just two, what is called in English, I don't know. You have just two possibilities. Let's say you have just two possibilities, 0 and 1. One bit has 0 and 1. And with these bits, you create these numbers. And I will not go dive into this one, but you should know this is the problem. Oops, why we have this crazy numbers here behind this and not this one here, because the builder of this PCs can't make this accurate from they can make it accurate only to a specific point, but then it becomes more and more inaccurate. This is the short and absolute bad explanation, but at least a good start if you have never heard about it. If you heard about this one, what I'm talking, then you probably know. And here we have to go to more things, and you would now have to, yes, you would now dive more into this math here, actually. I mean, in this double precision floating, and read here a little bit more, and then you will see what happens here, and then how they treat this number. You can see here they have also this strange number examples here on the bottom. So you see at start is all fine, but later all wrong. And yeah, I hope like I said, we don't dive into it. This is very mathematical because it's numbers and how the PC treat and create these numbers. It's more like this one in the real thing. It's not math, it's more like how the PC is creating numbers. So with that said, I skip this one and go to our next example, because I want to show you one more thing. And it is this one. Let's copy this one as well. Oops, let's go down. Oops, to main here. Let's jump here to this one, paste in. Now select this one here, uncomment this one, and now we test the other ones here. So this is the second code which you should test, because here you will see we get again problems, because we get not only problems here with the decimal points, you will see we get also problems with the points here in front, because normally when you watch this one and say, hey, wait a minute, when we get only problems behind, I don't know which digit here from this point, that's not so important, you would say, but sometimes it's very important. But that's not the worst part. It becomes even worse, and you will see here with this example here, if you run this, I hope, try to run this and try to see what happens. I start now this code. And now let's see what happens here. I create a floating number, but this time I have 9999999.0. You see, I have not so many digits behind, but I have many digits in front. And then I set the precision of this output here exactly to 9 digits. And then I printed out this float number here. And then this is another test. This one we can skip. Let's watch this one here first. And what happens is this float number here becomes 1000000, this one. And actually this is not accurate, right? This is wrong. Because I made here 9999999.0 and now I have 10000. So you can see we get problems. Not only behind, we get also problems in front. And if I set this one a little bit higher, let's see if we have still problems. We can test this one too. Okay, this one must be done again. So, and you can see this has nothing to do with this setting here. This has something to do just because this floating point number cause problems from there is a digit where it makes problems, and we have to read this in theory a little bit more, because I said this is a little bit too difficult to describe here. So let's continue here. Okay, we see we have not only problems behind the dot here, which means behind the decimal points, we have also problems here in front. And then let's go to the double here, and you see this number looks very easy, 0.1. What's the problem here with this little number here, right? And then you see I print this first out, but then let's see what I'm doing here. And then I print this out with 70 precision, right? And what happens with 70 precision here in this case, you can see the first output is expected. The second output is almost expected. You can see it. It starts with 0.1 and then 0, 0, 0. And here, you see this last one here, it starts there to make problems. And that I said, you don't have to understand all the math. The thing what you should understand right now is this PC, how he treats this number, how he creates this number. From a certain digit, it begins to make problems, which you can see in these examples. This is so at the start point. And let's see what happens here. So we have see this one makes a problem, and the last example is what happens here is I take this, I calculate now. I make here again double. I want a calculation, but what I do is I take this one double, and you see I add it 10 times. This is 10 times here double, and when I add it 10 times, then I expect 10 multiplied by this one, Control Z, by this one I expect 1.0, right? And the problem is it comes out this number here. It comes out 0.999999989, not 1. But I expected this one. So And the last question, why I'm explaining you this, why I'm showing you these examples. It's not important that you understand now how these numbers are created, but why I'm showing you this. First of all, of course, we have to understand in future how this works a little bit more in detail, but not right now. We are starters because this becomes a little bit technical. But the more important thing is, you must be very, very cautious, or you must be very careful when you work with numbers, because you have to know the computer can't make absolute perfect numbers. It's not creating absolute perfect numbers like in these examples. But we as a programmer, we are working like that we expect something. For example, here, if I said, okay, hey, I have here this double number calculation. I just take this double number, I add. I would expect now here this one, and later I would use this one here for other things. For example, I would say, okay, I can make this one with an if statement, for example, right? So I would go on and say, okay, this double number calculation is one, I can compare it, and then I can realize, I can set it as a condition. Let me show you what I mean. If double number calculation equal 1, because that's what I expected, right? That was my thinking, my logical thinking, which is actually right, but the computer, my PC, is not playing right. Then I would say, okay, if this is true, because if this one is doing that what I expect, yes, then print me out. Let's print out, yes, it works, right? So this is saying else, print me out. Let's make here else. No, it works not. Then let's write here std, say out. No, it works not. And something like that. So normally that can make a big problem in programming when we start now this one. And you see, we get here, no, it works not. The problem is your calculation, your thinking, your logical thinking was right. You can see this was okay, but you have not considered that the PC is not rounding, or let's say has errors in digits, and you must learn how to treat them. And then something like that can happen even it is not even your logic was right. You understand what I mean? That can cause many big problems in computers. So which means we have to understand this one a little bit more in detail. Actually, we have just later learn how we can be sure that when we make something like this one, it is actually this one. We will learn later this one later. In this repetition, I wanted to show you only that something like that can happen. You should be aware of this. And when you are working with numbers, you should know numbers are not accurate when the digits become more and more, because the PC can't represent the digits accurate. And yeah, then you have to read something like that. But I would not read like that, something like that here, because it's too technical probably and mathematical. You should read something like more for beginner friendly, which means they show you and explain it for beginners how they make it. Okay, I think I talked too much. Let's continue with our questions. I hope you get the idea that this one is very important. So, all right, let's go to 45. It says here, what is keyword for? Okay, write the syntax and use the syntax to make an example. Okay, then use the while loop syntax to make an equivalent code of your example. Okay, that's a lot of work. And then explain the examples on the page. Okay, that's a lot of work. Okay, perhaps it's so much work we should make a break, because I have here still 5 to go, and that would be too much because I talked already so much. Yes, let's make here a break. Normally I wanted to go here at least to 49, but we make here a break and start with this question in the next video. And with that I said, before we go on, I say perhaps you should dive into this kind of stuff a little bit and read why it's a problem, or let's say so, why there is a problem with numbers, to how PC create these numbers, and how we can avoid it, or how we can make sure that the numbers are right. Because if the numbers are not right, like I made this example before with this if statement, it can cause in many places big problems. In general, if you have very, let's say very full numbers, let's say full numbers makes not so much problems, but we see that's also not true, like this one here. It make a problem. It can make even more problems with full numbers, because the digits are important there as well. And yeah, you have to read this. This is a interesting topic. And yeah, with that said, if you have any questions or any complaints, like all time, write it in the comments. And if you have just suggestions or yeah, tips and tricks, write them as well. And with that said, good luck, bye, and we will continue here with this repetition in the next video. Good luck and bye.